In the 11th grade or maybe in the 10th grade, you classified physical quantities into two groups. One of them is scalar quantities. The other one is vector quantities. I think you classified them in the 10th grade, also in the 11th grade. You studied this. Scalar quantities are quantities which can be expressed by a number and a unit, like mass, 5 kilograms, temperature, 10 kelvins, linear speed, a speed, 2 meters per second, how fast it's moving, that's all. All these are scalar quantities. Mass, temperature, speed, even time, and some other quantities, they are called scalar. So, but there is a second type of quantities in physics, vector quantities. In here, vector quantities are expressed by a number and a unit, but not enough, and also direction. So if you need also direction to express a physical quantity, which means this quantity is a vector quantity, like force. Force is a vector quantity. 5 Newton, what is direction? Upward, downward, left, right. Which direction is the force? So that's why you need to express that. Force is a vector quantity. Displacement is a vector quantity, delta x, you studied last year. 10 meters displacement, but to which direction? To the east, to the west, to the north or south? Which one? So displacement is, that's why it's a vector quantity. And you are going to learn so different vector quantities in the 12th grade. Maybe last year you studied about also like electrostatic force. It's a kind of force. It's a vector quantity too. This year you will study in chapter 5, magnetic field. Last year you studied electric field. All they have directions. If there's a direction to express something, so it's a vector quantity. And also, last year you studied velocity. Velocity. Yes, it's a vector quantity. So 5 meters per second, to which direction? To the west, to the east, up, down. So it's called velocity. Velocity is a vector quantity. Velocity is different than speed. Speed doesn't involve the direction. We don't care. If we don't care the direction of the motion, so we express how fast it's moving by speed. But if you care about the direction of the motion, you express it by direction. It's a velocity. Velocity is a vector quantity for that reason. So, but speed is scalar quantity in physics. So then, velocity is a vector quantity that has both direction and also a magnitude. When we say magnitude, that number, this number is called magnitude. 5 meters per second in here is the magnitude. To the west is the direction. So velocity is a vector according to this. So velocity is a vector quantity that has both direction and also a magnitude. So then we can change a vector quantity by two ways. One of them, you can change its direction. Second one, you can change its magnitude. Every vector quantity can be changed by two ways. You can change its direction, or you can change its magnitude, or sometimes you can change both of them, both magnitude and direction. So there are several ways to change a vector quantity. But scalar quantity is not like this. If you want to change the mass, you are going to add mass. Add mass or remove mass, that's all. If it is 5 kilogram, make it 6 kilogram. If it is 6 kilogram, make it 3 kilogram by removing. So just add and remove. But vector quantity is not like this. So you can increase its magnitude. You can also change its direction, or you can do both of them. So velocity is a vector quantity that has both direction and magnitude. For that reason, we are going to change velocity by two ways. Velocity of an object can also be changed by two ways. One of them is by changing the magnitude of velocity. This magnitude of velocity, sometimes called, we can say, speed. Magnitude of velocity, just number. You are changing just the number of the velocity. Like you are, when it was 5, you are making it 6 meters per second. What is it? 6, you are making 10 meters per second. So just speeding up, or you can slow down. I mean, like if when it's your car is moving with 5 meters per second, so you slow down and make it 3 or make it 2, make 1. So by speeding up or by slowing down, you can change magnitude of velocity. And also you can change direction of motion. So when object is moving to the right, you change it to the left. When it is moving straight, you make it right. When it's moving down, make it up. So you can change the direction in many ways, and we will learn about them in this section. So you can turning the right or left, up and down, and turning back. All these are defining the change in direction of motion. So then you can also change velocity by changing direction of motion. And because velocity of an object moving a circular path can also be changed by 2 ways. One of them is changing the magnitude of the velocity along the circle. I mean, this horse can speed up or slow down. So by changing tangential speed. So object gains a tangential acceleration. We learned about that in the first title today. So horse speeds up or slows down along this circular path. So the horse can gain a tangential acceleration. And then remember, we got equation tangential acceleration as r times angular acceleration. It was like this, and we already did this. What about the second way? Is this horse changing direction of motion? Yes, it is moving like this in here. It's moving like this in here. It's moving like this in here. As you see, direction of the motion is also changing. So then velocity of the horse also changes because direction is changing. So second way is this. By changing direction of the motion, by changing direction of the velocity, so we can also change the velocity of this object, of this horse, which is moving on a circular path. Then velocity of an object moving a circular path also be changed by changing direction of motion, by changing direction of velocity. And if there's a change in velocity, which means there must be an acceleration too, because of this change in direction, this change in velocity. That acceleration, because of the change in direction of motion, only because of the change in direction of the motion. Look at direction. Continuously changing direction of the motion of this car, continuously changing. Because this direction is continuously changing direction of motion results a change in velocity, cause a change in velocity, and this change in velocity produces an acceleration, which is named as centripetal acceleration. That's why centripetal acceleration is defined like this. It is acceleration only due to change in direction of motion or due to the change in direction of velocity. That acceleration is called centripetal acceleration. Yani acceleration due to a change in direction of the motion or only due to a change in direction of velocity is called centripetal acceleration. I am repeating, this car moving on this circular path continuously changing direction of motion, continuously changing direction of motion. Because of this change in direction of the motion, this car also gains an acceleration which is called centripetal acceleration. Centripetal means towards the center or center seeking, center looking, which means, yeah, this acceleration must have a direction and its direction will be towards the center of the circular path. Now I will give a short break, not break about the lesson, but break into 12th grade because I will explain something to you about 11th grade. You studied, but which is very important. So remember, last year you only studied about object moving on a straight line path, correct? Objects are moving straight line path. speeding up from initial speed to a final speed, like this, like the one on the picture. So this object is speeding up along a straight line path from an initial speed to a final speed. When you are calculating the acceleration, you find the change in velocity, delta V. What is delta V? How do we calculate delta V? Delta V is final speed, final velocity minus initial velocity. Yani V final minus V initial. Always you should calculate delta V to calculate the acceleration. So now I am going to now remind you how to calculate delta V, V final minus V initial. In the 11th grade, you learn like this. To find the change in velocity, delta V is equal to V final minus V initial. Later, you wrote it like this. Delta V is equal to V final plus negative V initial. Vector in here, delta V, V final minus V initial, so which is equal to V final plus V initial. This negative V initial means negative. If you multiply a vector with negative, you are changing its direction. Yani V initial is in here, it is to the right, but you are going to make it to the left. It is in here to the right. So when you multiply it with negative, you are going to make it to the left. Multiplying a vector with negative number means this. So when you are adding the vector, when you are finding the change in velocity, you did this last year. You added V final with negative V initial. You added them. To add two vectors, rule is like this. Locate the first vector. I located the V final first in here. Then draw the second vector with its tail starting at the tip of the first vector. So from the tip of the first vector, locate the second vector. Locate the negative V initial. Negative V initial is what? In the opposite direction of V initial. And after that, the resultant vector is from the tail of the first vector to the tip of the last vector. So that was delta V. And you learned it like this last year to find delta V. But now I'm going to teach you a much easier way. So it is this. To find the change in velocity, locate two vectors so that their tails coincide. Yani V initial and V final. Their tails coincide. Locate two vectors so that their tails coincide. And after that, draw a directional line from the tip of the initial vector, initial V initial, to the tip of the final V final. You see that? They are the same. This and that are the same, but this is much easier than that. To get delta V, you are going to always use this method right now. The first one is very, very complicated. I will use again in here. Consider an object is speeding up along a circular line path. To find the velocity change, first, locate two vectors so that their tails coincide in here, and then draw a directional line from tip of the initial vector to the tip of the final vector, so you can easily get what delta V is. This is delta V, change in velocity. So if you look at delta V, you will see that delta V is in the same direction of the motion of the object. Object is moving to the right, delta V is to the right. If delta V is in the same direction of the motion of the object, object must be speeding up. If delta V and directional motions are in the same direction, so then object must be speeding up. First thing you should learn, you should remember and learn is this. If delta V and direction of the motion are in the same direction, object must be speeding up. Or if object is speeding up, delta V and direction of the motion must be the same. Second thing, get acceleration. Definition of acceleration is what? Delta V divided by delta T. This equation says you delta V and acceleration will be in the same direction because you divide a vector by a scalar, their direction does not change. Direction of delta V and acceleration are the same. If delta V is to the right, acceleration of the object also must be to the right. Acceleration is always always in the same direction of delta v. Whatever the direction of delta v is, acceleration will be in the same direction. A third thing is, of course, a force must be causing speeding up. There must be a force which causes this object to speed up. This force can be found according to Newton's second law of motion. Do you remember this equation? F is equal to mass times acceleration. Anybody remembers last year?
Yes.
Yes.
This equation says your force and acceleration always in the same direction. So if delta v and a are in the same direction, force acting on this object also must be in the same direction with the acceleration. Force F, acceleration A, delta v are always in the same direction. There is no exception. If there is a force, this force must cause an acceleration. If there's an acceleration, velocity must be changing. These are like chains. If one of them exists, the other two must exist. If there's an acceleration, there must be delta v. If there's an acceleration, there must be F. If there's delta v, there must be A. If there is delta v, there must be F. If there is F, there must be A. If there is F, there must be delta V. If one of them is to the right, the other two also to the right. If one of them is to the left, the other is also to the left. If one of them is upward, other two is also upward. So their directions are absolutely, indefinitely, no exception, same in physics. Also now I'm going to apply this to an object which is moving in a circular path. Remember, we said that because direction of the velocity continuously changing, this car will have a centripetal acceleration. Now I will get direction. It is not so hard. It will be very easy because I will apply the same rule again. Consider that a car is moving on a circular path with constant tangential speed. Yani value of the tangential is constant, 5, 5, 5, 5, 5, 5, or 10, 10, 10, 10, 10. However, direction is changing. Because direction is changing, there will be a delta V. So let's get delta V. Rule. Velocity change. Draw initial and final vectors so that their tails coincide. V initial, V final. Draw a directional line from the tip of the initial to the tip of the final. Delta V. Delta V is pointing where? Center. Delta V is pointing center of the circle. If delta V is pointing the center of the circle, what about the acceleration? What about the acceleration? Acceleration also must point to the center of the circle. This is called centripetal acceleration. That's why, because it's pointing the center of the circular path. You can choose another two positions. For example, initial, I said this is initial, this is final. Between these 2 points, what is direction of the centripetal acceleration? Let's get it. Put initial vector, then final vector so that their tails coincide. Draw a directional line from initial to final. Delta V again points to center. And if delta V is pointing to center, acceleration also must point to center. Centripetal acceleration always points to the center of the circular path. That's why it's called centripetal acceleration. It is named centripetal because centripetal acceleration itself is a vector quantity and its direction is towards the center of the circle at any instant. Now I will draw the picture. This is the picture of centripetal acceleration. As you see, the car is moving on circular path with constant tangential speed. Because tangential speed is constant, there is no tangential acceleration. However, direction is continuously changing. This change in direction causes an acceleration which is known as centripetal acceleration, and its direction is always towards the center of the circle. When car is here, so the centripetal acceleration will point to the center here, to the left. When car moves and comes here, direction of centripetal acceleration again to the center, but this time down. When car arrives to the left side of the circle, centripetal acceleration points towards the center, but this time to the right. When car comes to the the bottom of the track according to my screen. So the centripetal acceleration points to center, but this time upward. But always points the center of the circular path, but direction of the centripetal acceleration continuously changing. Left, down, right, up. I'm just taking 4 points. Of course, there are other points. When it is here, it's going to be like this. When car is here, it's going to be like this. When car comes here, it's going to be like this. When car is here, it's going to be like this. Always, centripetal acceleration will point towards the center of the circular path. I want you to check this figure. Tell me the angle between tangential speed and centripetal acceleration. How much is the angle?
90 degrees.
90 degrees.
Yes, this is the ministry exam question. What is the angle between tangential speed, or the direction of the tangential velocity, they are asking like this, and centripetal acceleration? Always 90 degrees. So this angle is always 90 degrees, 90 degrees, 90 degrees. At any position on this circular path, the angle between VT and AC is 90 degrees. One more thing you should know. Centripetal acceleration is always along the radius. You see it? Along the radius. Along the radius. Along the radius. Along the radius. Centripetal acceleration always along the radius of circular path and always towards the center. Definition of centripetal acceleration. One definition is clear. I gave that, which is centripetal acceleration is due to the change in direction of motion or direction of the velocity. But there is one more definition of centripetal acceleration, which is one of the ministry exam question. Now I am going to try to explain that. Velocity vector of an object is continuously shifting, changing, yes, changing. Definition of the centripetal acceleration is also expressed according to change in direction of velocity. This is the definition of the centripetal acceleration, which is asked in ministry exam. They said that, yes, direction of the velocity vector is continuously changing by time. That's why it is the time rate. Time rate means change divided by delta t. Time rate of change, yani variation means change. Time rate of variation of direction of velocity. Time rate of variation of direction of velocity when object moves on a circular path is called centripetal acceleration. This definition is one of the ministry exam question. They ask it like this. The time rate of variation of direction of velocity when an object moves on a circular path is called what? So it is called centripetal acceleration. So magnitude of centripetal acceleration. In fact, there's the equation is very simple, but I will try to make you get this equation on your own. Assume that you are running on a circular path. In which of the following cases you can change direction quicker?
Oh, when I run fast.
That's the point. When you run fast, which means magnitude of the centripetal acceleration is proportional to your speed. If you run faster, because you change your direction quicker, so centripetal acceleration must be greater. Centripetal acceleration increases with your speed. When you run faster, centripetal acceleration will be greater. Second thing is this. Assume there are two circles. There are two circles. One circular path is small. Other circular path is so big, so large. And you are running on these two circular paths. In which circular path you change your direction quicker? Small circle or large circle?
Small circle.
Of course, small circle, because small circle you are going to turn very quickly. That's why when you make circle smaller, and the radius gets smaller, centripetal acceleration will get bigger. That is why centripetal acceleration's magnitude is proportional to velocity's magnitude of velocity. Yani what's squared? It is inversely proportional to radius of the circular path, and equation, that is why this equation says you centripetal acceleration is proportional to square of the speed. When you increase your speed on the circular path, centripetal acceleration increases. But if you run instead in a small circle, yani with a smaller radius, then in this case centripetal acceleration will be greater. Yani centripetal acceleration will be calculated by tangential speed squared divided by r. This is the equation how we calculate magnitude of centripetal acceleration. So AC is Vt squared over r is the equation for calculating the centripetal acceleration. And sometimes we can insert instead of Vt r times omega. Remember, tangential speed is equal to r times omega. If we insert it here, r times omega, it is also possible to write this equation in terms of angular speed. R squared omega squared over r, so square will can simplify. You will get a second equivalent equation, but another version of centripetal acceleration, radius of the circular path multiplied by angular speed of that moving object. So you can also calculate centripetal acceleration by this one. So these two equations are equivalent, only you are going to check the question. In the question, tangential speed is given or angular speed is given. If tangential speed is given in the question, you are going to use this one. But if angular speed is given in the question, you are going to use the second one. AC is equal to r times omega squared. Unit of centripetal acceleration is the same as the usual linear accelerations because it is meter per second. Square of meter per second is meter squared over second squared divided by meter. It becomes meter per second squared, the usual unit of linear acceleration according to these equations. And we will solve two problems about the centripetal acceleration. Calculating the magnitude is not so hard. Equations are very clear. This test car moves at a constant speed around a circular track. We said that, yeah, it's moving something like this. A car is moving on a circular path with constant tangential speed, but it's moving a circular path. So then direction is continuously changing, so we should be able to calculate the centripetal acceleration. And in the question, centripetal acceleration is given. It says that if the car is 48.2 meters from track center, distance to the circular track or circle center is called what? It's called radius, of course. Distance from the object to the center is called radius. Radius of the circular path is 48.2 meters. And this car has a centripetal acceleration in magnitude. As you see, it's given in magnitude. So positive. For 8.05 meters per second squared. So AC is 8.05 meters per second squared. What is its tangential speed? Calculate its tangential speed, Vt. And equation for calculating the centripetal acceleration, because we have tangential speed asked, you should use the first equation. Of course, the first one includes the tangential speed AC is equal to Vt squared divided by r. But Vt is asked cross product. You are going to cross product these two. So Vt is going to be, or Vt squared is going to be r times AC. Then you are going to get the square root of both sides. So then you will get Vt is equal to root of r times AC. R is given 48.2, AC is given as 8.05. You will insert these two given into the equation. After that, you are going to do your calculation. Be careful about the brackets. When it is inside the bracket, you should put one bracket to the beginning, one bracket to the end, root, bracket, 48.2 multiplied by 8.05, close the bracket, press equal, you are going to get 19.7 meters per second. So this car is moving on this circular path with a tangential speed of 19.7 meters per second. And one more, a race car moves along a circular track at an angular speed. Now, in this practice problem 1, speed is not given in linear or tangential, it's given angular, yani omega is given. A race car moves along a circular track at angular speed of 0.512 radian per second. So omega is 0.512 radian per second. If the car's centripetal acceleration is 15.5 meter per second squared. So AC is 15.4 meter per second squared. What is the distance between the car and the center of the track? Of course, distance between the object and the center of track is called radius. So in this case, you are going to calculate what radius is. But because angular speed is given, we are going to use the second equation, which includes omega, which is r times omega squared. So AC is equal to r times omega squared. Okay, then we will, to get r, we should divide both sides by omega squared, divide by omega squared. So you will get r as AC divided by omega squared. AC is 15.4. So omega is 0.512, but squared. When you do this calculation, you are going to get the result as 58.7 meters. Now, look at this picture. A car is accelerating from rest in a circular path. So car is initially here, and it is speeding up 10. Speeding up 20, speeding up 30. So as you see, speed of the car is increasing. If speed increases, so which means tangential speed, tangential acceleration also must be calculated. In here, we are going to calculate two accelerations, or this car will have two accelerations. One of them is because magnitude of the velocity is changing from 0 to 10, from 10 to 20, from 20 to 30, from 30 to 40, and so on. We will calculate a tangential acceleration. And second, because direction of velocity is changing as the car is moving, we are going to calculate a centripetal acceleration. In here, this car has an acceleration which has two components. One component, because car is speeding up, it's going to be a tangential acceleration. Second component, because direction of the motion or direction of the velocity is changing, car will have a centripetal acceleration. Then I'm going to combine them. The first one, change in tangential speed produces tangential acceleration. Speeding up on the circular path or slowing down on the circular path produces tangential acceleration, and we know that tangential acceleration is tangent to the circle at any instant. For example, if I want to draw tangential acceleration, I have to draw a tangent line. So this is going to be tangential acceleration for this car if it is speeding up on this circular path. But this car, as it is moving on this circular path, it's also changing direction. Continuously changing direction produces a centripetal acceleration, which is AC. And we know that centripetal acceleration direction is always towards the center of the circle. When car is here, so it must be towards the center of the circular path. Yani this car will have these two components, tangential component and centripetal component. Of course, I can find total acceleration of this car by adding these two vectors. One vector is tangential component, other vector is centripetal component. I am going to add them and I am going to calculate the total acceleration. Total acceleration of the car at that point is found by vector addition of AT and AC. AT is this one, AC is that one. I mean, AC is tangent to the circle, AC is to the center of the circle. Now let's combine them on one circle. So this is AT, this is AC. Use parallelogram method you studied in the 11th grade to get the total acceleration. So it can be calculated, of course, by Pythagorean theorem. So which is AC squared plus AT squared. The magnitude of the total acceleration can be found using the Pythagorean theorem, which can be calculated AC squared plus AT squared square root. This is the rule for calculating the magnitude of total acceleration of this car at that point. How can you get this angle? You see here is a right angle triangle.
Yes.
This right angle triangle, if I say this angle is theta, this angle is theta, I can calculate this theta by using definition of tangent. Tangent was opposite leg of the right angle triangle divided by adjacent leg. Do you remember it? Tangent theta, opposite side or opposite leg, which is AC, divided by adjacent leg or adjacent side, which is AT. By dividing AC by AT, it is possible to get the tangent of this angle. Then you are going to inverse it to calculate the angle theta, which is inverse of tangent. Bracket AC over AT is the equation to calculate the angle to the or direction of the total acceleration with respect to this vertical line. Fortunately, you are not going to calculate anything. Only you are going to learn about this equation, how to calculate tangent theta in this motion, in the motion of this car. So then we can say that direction of total acceleration can be calculated by inverse of tangent AC divided by AT and depends on the magnitude of each component of the acceleration. Yani centripetal component divided by tangential component, inverse it, you will get the direction of total acceleration of this moving object, moving car. I will try to give a diagram to you which explains all the accelerations we learned in this section. I will put on a diagram. This diagram includes all accelerations we learned in section 1 and section 2. The first one is, remember, angular acceleration we studied in section 1. When angular speed of an object is changing, alpha, we calculated alpha as delta V over delta T. This is the first one. And in section 2, we said that if an object is speeding up or slowing down, like the carousel, I mean, if the horse on the carousel is speeding up or slowing down, we can also write an acceleration because of the change in tangential speed, which is known as tangential acceleration. And angular acceleration and tangential acceleration, they are related by equation AT is equal to R times alpha. But these two accelerations are from the same reason, from the same cause. Cause of these two accelerations is speeding up or slowing down along the circular path. And today, in the last lesson, we learned a new but completely different nature of acceleration, which is called centripetal acceleration. So this centripetal acceleration is because of the change in direction of motion. But when we combine these two types of acceleration by Pythagorean theorem, we calculated the total acceleration as root of AC squared plus AT squared. Sometimes they are doing this thing. Instead of AT, what can I write? AT is equal to R alpha. It's possible to rewrite this equation as, so AT is equal to root of AC squared plus, instead of AT, I can insert R times alpha. It becomes R alpha squared. This is also alternative form of that equation.